we learned that aromaticity is not only applied to carbocyclic systems or cycles, if you like, that consist of carbon atoms only. It can also be applied to heterocyclic systems, if you like, or heterocyclic compounds, cyclic compounds that consist of atoms, not only carbon, but other heteroatoms such as nitrogen, for example, oxygen, sulfur, and so on. We took previously pyridine as a typical 6-membered heterocyclic compound as an example of an aromatic heterocyclic compound. We took also pyrimidine as another example of a 6-member heterocycle, which is also aromatic. Let's now take 5-membered heterocycles, and of course the usual suspect here is actually pyrrole. So pyrrole is a 5-membered heterocycle that consists, of course, of 5 atoms. It's a 5-membered heterocycle, and of course this nitrogen again, it has a lone pair. Now pyrrole again is a 5-membered heterocycle. It consists of 5 atoms. Of course it is a heterocycle because it contains nitrogen, which is a heteroatom, different from carbon. Now a good question would be, is pyrrole aromatic? Pyrrole is found actually to be aromatic experimentally. So this is pyrrole. It is found to be aromatic. So let's explore that. Is pyrrole cyclic? Yes, it is cyclic. It is cyclic. Pyrrole. Is it planar or flat? Yes, it is planar or flat. It is flat in shape. Is it conjugated? Well, if it is aromatic, it has to be conjugated. Yeah. So, and of course, there is a p orbital here as usual on each of these carbon atoms. And of course, for pyrrole to be aromatic, this lone pair must be located or situated in a p orbital for efficient overlap, if you like, continuous overlap on the pyrrole ring. This lone pair is located in a p orbital. So again, this is in a p, or the lone pair is in a p orbital, and this is a significant difference between 5-membered heterocycles, exemplified in this case by pyrrole, and of course 6-member heterocycles which contain an imine functionality. Remember, the lone pair on nitrogen in the imine functionality is not, in pyridine for example, is not inside the pi system, it's actually outside. It's an sp2 hybrid orbital. But here the scenario is actually different. This lone pair is situated in a p orbital. It is inside the pi system, which is important or essential, okay, for the cyclic conjugation, which in turn is essential for aromaticity of pyrrole. So pyrrole is conjugated, therefore it is conjugated. That's because nitrogen has a lone pair in a p orbital, so it is conjugated. Now, is it 4n plus 2? Well, the pyrrole contains 2 pi electrons here, plus 2, 4, and these 2 electrons, since they are inside the pi system, they are considered to be pi electrons. So 2 plus 2 plus 2, so that's 6. So 6 pi electrons in pyrrole. Therefore, pyrrole is aromatic. It is aromatic pyrrole. That's because for one remarkable difference, or one remarkable reason, is that this lone pair is actually in a p orbital. It is inside the pi system. The p orbital not only entitles pyrrole to be conjugated, or conjugation inside to be continuous, if you like, or cyclic. Also, this accounts, okay, for the number of pi electrons, which is 6, and that's of course in accordance with the Huckel rule. Therefore, it's 4n plus 2. This number is, and therefore pyrrole is aromatic. Let's now take another 5-member heterocycle, but this time we take an example that contains also not only nitrogen but another heteroatom. So let's take imidazole, this time, imidazole, imidazole is a 5-membered heterocycle, of course, that contains nitrogen. So here it's actually similar to pyrrole, but also imidazole contains an imine function group. So in that, it's actually similar to 6-member heterocycles such as pyridine. So this is imidazole. And since it resembles 5-member heterocycles such as pyrrole here, therefore the lone pair is actually inside the pi system. Therefore, that lone pair must be situated or located in a p orbital. Now, the lone pair on this nitrogen, or the imine nitrogen, is actually outside. So this is outside the pi system. It's not inside, so therefore it's not counted therefore as pi electrons, whereas the lone pair on nitrogen is counted. So there are 2 pi electrons therefore on nitrogen. That's because, again, they are located in a p orbital. So is imidazole cyclic? Of course it is cyclic. So it is cyclic. Is it flat or planar? Yes, it is flat or planar. Now, is it conjugated? That's a very important question. Well, since that lone pair is located in a p orbital, so there is a p orbital here. There is, of course, a p orbital on all other atoms, such as these 2 carbons and that one, because they are doubly bonded with nearby atoms. This nitrogen, since it has a double bond with this carbon, therefore it must have a p orbital. So there is a p orbital here also on nitrogen. But remember, that lone pair is not in the p orbital. Okay, that lone pair is outside the pi system. It's in an sp2 hybrid orbital. Now, because of this, or since there is a p orbital on each of these atoms, on all atoms actually in the imidazole ring, therefore imidazole is conjugated. There is cyclic conjugation inside. Conjugation is continuous, if you like, or not disrupted. Now, the number of pi electrons, well, 2 here, 2 there, that's 4, plus 2, because remember these 2 electrons are inside, they're in a p orbital, so they participate in the cyclic conjugation. So therefore, there are 6 pi electrons in imidazole. 6 pi electrons, and of course, if it is 6 pi electrons, this is just like, it's 4n plus 2, it's Hooker rule, basically, just like pyridine, just like pyrrole. So therefore, imidazole, since it has fulfilled all aromaticity requirements, it is aromatic. So imidazole, being a heterocycle, a 5-membered heterocyclic compound, is aromatic because it is cyclic, it is conjugated, it is flat, it has 6 pi electrons. What's very remarkable here, very, very interesting, is that imidazole has actually common characteristics of 5-member heterocycles on one hand, such as pyrrole, of course, and 6-member heterocycles on the other, just like pyridine, because on this side, if you like, or here, it's actually it resembles 5-member heterocycles, just like pyrrole, and here, because it contains an imine function group, therefore it resembles 6-membered heterocycles. Remember, the lone pair on this nitrogen is inside the pi system, so this is inside the pi system, whereas that lone pair on the imine nitrogen is actually outside. In summary, imidazole is a 5-member heterocycle which is aromatic, and it is aromatic just like the typical 5-member heterocycle, which is pyrrole. Both of these heterocycles obey aromaticity rules. They are both cyclic, both conjugated, both flat, and both obey the Hooker rule, which is 4n plus 2.